right? So let us begin our today's session. So this is the problem. The plane Lx plus my equal to 0 is rotated about its line of intersection with the plane z equal to 0 through an angle alpha. Show that the equation of plane in its new position is so please take a note of this problem. So this question seems to be that problem taken from planes. So if you view it as the problem from the lines perspective, it is also correct. So it belongs to both the chapters. So occasionally some problems are interrelated with the planes chapter. So is the question problem clear for everyone? What it is asked actually there? So if you visualize that the first plane is Lx plus my equal to 0. The second plane is z is equal to 0. So here you will get a line of intersection. Now what happens if you rotate this plane over this line of intersection, then its equation in the new position is this one. And how much you are rotating? It is just like flipping the plane from one position to the other position through an angle alpha. Clear? Right. Now, since you are calculating the plane equation which is containing this line, so we have to use the formula pi 1 plus lambda pi 2 equal to 0. So here pi 1 is nothing but the given plane Lx plus my equal to 0, and pi 2 is nothing but the plane z equal to 0. So if you apply Lx plus my plus lambda z equal to 0. So if you can calculate the value of lambda on substituting this, you will get the required plane equation. Obviously, if you observe the solution of the question, lambda value should be square root of L square plus m square into tan alpha. Can you compare the two equations? Say. Now it is given that the new plane and the given plane Lx plus my equal to 0 has an angle alpha between them. So let us consider the angle formula from the new plane and the given plane, because when the plane is rotated through an angle of alpha, this is the new plane you have obtained. So considering cos alpha value there, since you don't know whether it is acute angle or obtuse angle, I take a modulus in the numerator. So cos alpha is equal to modulus of L square plus m square by square root of L square plus m square into square root of L square plus m square plus lambda square. I have applied the cos theta formula. A1 A2 plus B1 B2 plus C1 C2 by square root of for this plane and this plane. Now let us take reciprocal on both sides and let us do squaring on both sides. Then you have secant square alpha is equal to L square plus m square into L square plus m square plus lambda square whole by L square plus m square whole square. So square, the term gets cancelled. So if you separate the values, you have secant square alpha is equal to 1 plus lambda square by L square plus m square implies secant square alpha minus 1 is nothing but tan square alpha. So tan square alpha into L square plus m square is equal to lambda square, implies taking square root on both sides, lambda is equal to plus or minus square root of L square plus m square into tan alpha. So please check the simplification part. If you have any questions, you can ask. So if we substitute lambda value there in the new plane equation, you will get the required solution of the problem. Is it clear to all? Right. So I will take the other model then. Now before going to that, let us imagine, suppose I have a line equation given in symmetric form and I have a plane equation. Now if I said that the line intersects the plane, so what could be the check-in condition for it? Can you guess? And if there is an angle between them, how to calculate the angle? So for this purpose, there is a small formula. If you take that theta is the angle between the line and the plane, so apart from calculating cos theta, here we calculate sin theta. So sin theta is equal to AL plus BM plus CN by square root of A square plus B square plus C square into square root of L square plus M square plus N square. So this is the formula we consider to calculate the angle between line and plane. Okay. So if the line completely lies on the plane, so let us imagine that this is the plane and the line completely lies on it. then what happens? The point on the line x1, y1, z1 satisfies the plane equation. So you have ax1 plus by1 plus cz1 plus d equal to 0. And also, since the normal of the plane is perpendicular to anything on the plane, so these two are perpendicular, hence applying the perpendicularity condition, we will have AL plus BM plus CN equal to 0. So these two conditions will be satisfied by the line if it completely lies on the plane. Okay? Is it clear to all? Please take a note of the formula. Now, the next context is, I have considered the line in symmetric form. This is the line I have considered. I want to calculate the equation of a plane which is containing two lines, and also I want to find the equation of a plane which contains the first line and parallel to another line whose DCs are nothing but L2, M2, N2. So if you visualize the picture, let us say this is my line equation L1. I want to calculate the equation of a plane which is containing this one or passing through this one, and this plane is parallel to another line. Sometimes this plane contains this one also. So for that, the formula is determinant of x minus x1, y minus y1, z minus z1, L1, M1, N1 and L2, M2, N2 equal to 0. So this is the formula, we make use of that. Yeah. This is the given line L1. I want to calculate a new plane which is passing through the line, and this plane is parallel to another line whose DCs are this. Okay? Right. That was the formula. Now, the same formula is also useful to calculate the equation of a plane containing the two lines. The same formula is useful to calculate the plane equation which is containing the two lines. So here, if the plane contains the two lines, these two lines we call them as coplanar. Accepted? They belong to the same plane. So here we introduce a new concept that if I want to know whether two lines are coplanar or not, what I have to do? That is one. How to calculate the point of intersection between two lines when they intersect. And the other one is, if we discuss about the coplanarity, we need to consider three cases. That we are calculating the coplanarity between the lines. Since we have different representations for the lines, the possible cases are, I have considered L1 and L2 both in symmetric form. That means L1 is written in this model, L2 is also written in this model. So in that case, we are going to check with the coplanarity. Second one is, I have taken L1 in symmetric form, L2 in unsymmetric form. So among the two lines, one is in symmetric, the other one is in the unsymmetric form. And third case is obviously both the lines are taken in unsymmetric form. Then how to calculate the coplanarity and verifying the coplanarity. Okay? This is the perspective. Clear? Yeah. Here the condition is nothing but we are going to check the lines are coplanar or not. In other words, if two lines are coplanar, we should be able to calculate a plane which is containing them. Am I correct? So what happens? We are going to verify coplanarity, or we are going to find the plane which is containing the given lines under three possible cases. First case, both lines are in symmetric form. That means both line equations are given in this pattern. Second, one line in this pattern, another one is unsymmetric form. Nothing but two plane equations are given apart from giving L2 straight away. And third model is both the lines are given in unsymmetric form. That's it. Clear now? Right. Now let us take the first problem. Now let us take that the first problem as please take a note of the line equations. Now remember one point that whenever two lines are coplanar, the possibility for them is the two lines must be parallel or the two lines must be intersecting. So if you say that the two lines are coplanar, obviously the two must be either parallel or intersecting if they belong to same plane. That was the property. Now if you observe the drs of the two lines, are they parallel? That means, are they satisfying the condition that A1 by A2 is equal to B1 by B2 is equal to C1 by C2? If the drs satisfy that condition, they are parallel. Right? The second thing is, you are going to verify the intersection. That means you are going to prove the two lines are intersecting. How to? You need to calculate the point of intersection for them. If point of intersection existed, then you are done. Okay? Are you getting the context behind it? Right. The another one is how we are going to calculate the plane which is containing both the lines. That is very simple. I have given the formula earlier. So the plane containing the two lines is straight away obtained from the formula that determinant of, you take the first line, x minus 1, y plus 1, z plus 10, 2 minus 3, 8, 1 minus 4, 7 equal to 0. This is the formula straight away we apply. So if you consider this formula, the equation of the plane will be 11x minus 6y minus 5z minus 67 equal to 0. So finding the equation of plane containing the lines is very easy. You have a straightaway formula available to us. The second thing is how to calculate the point of intersection. Let us discuss that. So please take a note of these two values. After noting, please tell. So the det will be, so you are saying that when the lines are non-coplanar, what will be det of them? It's very simple that the det will not exist, it will become 0. The lines will become dependent, right? So actually, if the lines are not coplanar, the drs will be perpendicular. A1, A2 plus B1, B2 plus C1, C2 equal to 0. By observing that, we can say like that. And point of intersection will not exist there. Because they are not coplanar. Right. So let us write the parametric form. So whenever the two line equations are given to us, immediately we check for two things. First, whether the drs are parallel or not. It means A1 by A2 is equal to B1 by B2 is equal to C1 by C2. If it is so, we are able to find a plane containing them. If they are perpendicular, immediately we can say that they are non-coplanar. There is no need to go for the determinant again. Because whenever the two planes are coplanar, either of the conditions must be satisfied, that they are intersecting or they are parallel. So based on that, we solve the problem. Okay? Are you clear now? Right. So if you write the parametric form, x is equal to 2r plus 1, y is equal to minus 3r minus 1, z is equal to 8r minus 10. And for the second one, x is equal to s plus 4, y is equal to minus 4s minus 3, z is equal to 7s minus 1. So if you feel that the two lines are intersecting, they should share the point of intersection. It means that for some r value and for some s value, these coordinates are equal because the point belongs to both the lines. So it belongs to line 1, it belongs to line 2. So for some r value here, for some s value here, both must be equal. So if you make the respective coordinates as equal, you will have 2r plus 1 is equal to s plus 4, minus 3r minus 1 is equal to minus 4s minus 3, and 8r minus 10 is equal to 7s minus 1. Now if you simplify them, you will get the respective equations in r and s. However, straight away I will write the values of r and s. So you will get r is equal to 2 and s is equal to 1. So you can take either of the thing. So if you take r, substitute the value here. If you take s, substitute the value here. Then the point of intersection would be 5 minus 7, 6. This is the point of intersection. Since you are able to calculate the point of intersection, they are coplanar. In this way, we conclude the solution. Clear to all? Please take a note of that. Then I will take the other model. So this problem is based on two lines given in symmetric form. Let us take the mixed case. So the problem is given that show that this is the problem. Please take a note of it. So here in this one, we have considered the mixed case. So one line is in symmetric form, the other one is in unsymmetric form. So if you have a rough visualization for the problem, say this is the second line which is given in unsymmetric form. The intersection of two planes. And the first line is given in symmetric form. So let us straight away like this. This is L1, this is L2. So if you are able to find the point of intersection, then automatically you can show that the two lines are intersecting. Agreed? Right. So for the first line, let us write the parametric form, which is nothing but, if you take that this is equal to r, then x equal to r minus 1, y is equal to 2r minus 1, z is equal to 3r minus 1. So for different values of r, you are getting different points on line 1. So for a particular value of r, the point belongs to the intersection. So if the point belongs to the second line, it means that the point belongs to the both the lines, I mean both the planes. So what happens, in order to determine r value, you can consider any one plane and you substitute x, y, z coordinates there. So you have r minus 1 plus 2 into 2r minus 1 plus 3 into 3r minus 1 minus 8 equal to 0. So I have considered the first plane of the second line which is given in unsymmetric form, and I have substituted the respective coordinates there. So if you simplify that, you will get the value of r as hence the point of intersection will be 0, 1 and 2. Please note that. Is it clear? If you have a small doubt that, you can substitute the point 0, 1, 2 in the second plane equation and you can recheck that whether it is satisfying or not. So you can conclude that 0, 1, 2 is the respective point of intersection. accepted? Any doubts for anybody over this approach? Please tell. I am leaving the simplification part towards you because getting the idea and procedure is more important than the simplification. Because if I write the elaborated solution, it occupies the total board. I need to erase multiple times. So if you are interested, I will write the complete solution of it. How to simplify the part, getting R value. Is it required? Right. Then we did half part of the problem. The second one is we have to calculate the plane which is containing them. So let us visualize this. So you are going to have the plane equation containing the two lines. Now, how to evaluate this? Because since you are finding the point of intersection, you can do the rough work for checking the second plane, obviously. Because if the line intersects only the first plane, how can you say that they both intersect? There is something different, right? That's why we need to check for that. So if at all, in order to calculate R, you can do the other method that apart from substituting the coordinates in the first plane equation, you can take the second plane also. Either of the thing will give exact R value which depicts the point of intersection. That's it. All right. Now, to calculate the plane containing them, I will do like this. So, I am going to write the plane equation which is containing the second line. Why I am writing? Because the second line is given in unsymmetric form. Straight away I got a formula. Pi 1 plus lambda pi 2 equal to 0. So if you apply that, x plus 2y plus 3z minus 8 plus lambda into 2x plus 3y plus 4z minus 11 equal to 0. So did you get the idea why I have taken that formula to calculate the plane equation? Any doubts? So let us take the terms as common. Then you have 1 plus 2 lambda into x, 2 plus 3 lambda into y, plus 3 plus 4 lambda into z, minus 8 minus 11 lambda equal to 0. So please understand that the plane equation what I considered contains both the lines. It contains line 2 as well as line 1. In that way, I have written like that. So, if you consider the normal to the plane, which is perpendicular to the required plane, it is perpendicular to both the lines which are on that plane. So, this normal is perpendicular to the first line, hence we can apply perpendicularity formula for the drs of the line 1 and the normal. So these are the drs of the normal, and 1, 2, 3 are drs of line 1. Let us apply that. So 1 into 1 plus 2 lambda plus 2 into 2 plus 3 lambda plus 3 into 3 plus 4 lambda equal to 0. So if you simplify that, I will say you are going to get lambda value as minus 7 by 10. So if you substitute lambda value at this position, the required plane equation would be 4x plus y minus 2z plus 3 equal to 0 on simplifying that. So is the idea clear for everyone? Why I have considered pi 1 plus lambda pi 2? How I evaluated lambda using the first line? So please take a note of that. So when the two lines are of the mixed type, in order to verify coplanarity and the plane containing them, we will follow this technique. After noting this, please tell. Now let us take the third case where the two lines are given in unsymmetric form, right? So this is the problem I wish to take. So please take a note of it. So here we have to verify whether the two lines which are given in unsymmetric form are coplanar or not. If they are coplanar, then we have to calculate the plane containing them. That was the question tag for this problem. We need to check whether they are coplanar or not. That is first one. Second, if they are coplanar, then find the plane which is containing them. Okay? Now, for this, in order to verify the coplanarity, the checking condition is simply calculate the determinant writing all the coefficients of the planes. So here 7 minus 4, 7, 16, 4, 3, minus 2, 3, 1, minus 3, 4, 6, 1, minus 1, 1, 1. I have simply written all the coefficients of the four planes. So in order to evaluate the determinant of the 4 by 4 matrix, as we know, determinant can be expanded by means of any row or column. So I want to make use of the column. So I will apply necessary row operations. Then I want to calculate the determinant. So if you exchange first row and last row, it will come 1, minus 1, 1, 1. 4, 3, minus 2, 3, 1, minus 3, 4, 6, 7, minus 4, 7, 16. Now, if we apply the row operations, R2 tends to R2 minus 4, R1, etc., it is going to come as 1, minus 1, 1, 1. So you have the things 0, 3, 0, 9 here, and it will be so this is a thing after applying the row operations. R2 tends to R2 minus 4 R1, R3 tends to R3 minus R1, R4 tends to R4 minus 7 R1. Now, I am calculating the determinant by means of the first column. because determinant can be evaluated by using any row or column. So taking 1 here, 1 into determinant of 7 minus 6 minus 1 minus 2 3 5 3 0 9. So if you consider the remaining things, plus 0 plus 0 plus 0. So if you calculate the determinant of that 3 by 3 matrix, it will become 0 obviously. Or you can evaluate that by doing necessary row operations so that 2 rows will become equal, hence it is 0, the net value. Since the determinant becomes 0, hence we can say that the given 2 lines are coplanar. So please take a note of it. Any questions you can ask. Alright. Now, coming for the plane containing them, it is a little lengthy procedure. It involves a little calculation only, not that much difficult. So the technique here is, first of all, I will calculate a plane passing through line 1. And I will calculate a plane passing through line 2. Now what happens if the 2 lines are coplanar? These 2 are nothing but same. Accepted? I have taken the plane equation containing L1. I have taken plane equation containing L2. If the 2 lines are coplanar, obviously these 2 should give the same plane equation. In other words, if you consider x, y, z coefficients here, they are proportional. Fine. So in this way, we will evaluate lambda and mu value so that we can compute the plane equation, the plane containing the 2 lines. So how we are going to do? So for the first line, we apply pi 1 plus lambda pi 2 equal to 0. Taking the coefficients as common, I will write one more step, 7x minus 4y plus 7z plus 16 plus lambda into 4x plus 3y minus 2z plus 3 equal to 0. Taking the terms as common, 7 plus 4 lambda into x plus minus 4 plus 3 lambda into y plus 7 minus 2 lambda into z plus 16 plus 3 lambda equal to 0. So for the second line, we consider say pi 3 plus mu pi 4 equal to 0, which gives that x minus 3y plus 4z plus 6 plus mu into x minus y plus z plus 1 equal to 0, which gives that x plus mu into x, 1 plus mu into x plus minus 3 minus mu into y plus 4 plus mu into z plus 6 plus mu equal to 0. So what I am saying, the planes are same, so that the coefficients are proportional. So we consider that 7 plus 4 lambda by 1 plus mu is equal to 3 lambda minus 4 by minus 3 minus mu is equal to 7 minus 2 lambda by 4 plus mu. So these 3 values are equal, I mean proportional. We take the constant k. So I am taking that both are same planes, then the coefficients must be equal, right? So apart from saying that, I am saying that the coefficients are proportional. So if both planes are parallel, in that case also we take the proportionality constant k. Because if you imagine that, so just take that, suppose you take the railway track, this is one line, this is one line. So the wood which is underlying them is nothing but the plane containing them. Accepted? Now what happens, if you consider other plane, they may be parallel. If you consider the same plane, then it is different. Clear? So just understand like that for the visualization part. Right. So I want to give the minimization for simplification part. I will give the rough idea how to solve it, because it takes a lengthy procedure. If you write it on paper, it nearly takes 2.5 pages for the entire thing, or 2 pages. So taking the proportionality constant, you have 7 plus 4 lambda is equal to k into 1 plus mu. 3 lambda minus 4 is equal to k into minus 3 minus mu. 7 minus 2 lambda is equal to k into 4 plus mu. Now what happens, if you simplify the equations, you will get 3 variables, lambda, mu and the product mu k, 3 variables. However, I just want to write the respective equations. You will get them as 4 lambda minus k minus mu k is equal to 7 minus 7. Then you have 3 lambda plus 3k plus mu k is equal to 4, and you have minus 2 lambda minus 4k minus mu k is equal to minus 7. All right. You can compare the constants also. That also you can do. Now what happens? Let us take the first 2 equations. If you add them, the common variable mu k gets cancelled. Again, if you add these 2, the product variable mu k gets cancelled. So you will get an equation in lambda and k only. So solving that, you will get lambda is equal to minus 1 and k is equal to 2. So once you know what is k, immediately substituting the values in any one of the equations, you will get that mu is equal to half. Now the final part is to determine the plane containing of both lines. You can take either lambda or mu. If you take lambda, substitute in this equation. If you consider mu, substitute in this equation. So the final answer will be 3x minus 7y plus 9z plus 13 equal to 0. That was the final answer. Okay, so it just involves the simplification part, because you need to write the number of equations, you have to solve them. Finally, you are substituting the value either lambda or mu and you are getting the required plane equation. That's it. Fine. So if you have noted this, please tell me. I want to take the other part. So the next one is find the equation of the line through the point please take a note of it. After that, tell. Right. Now, here the objective of the question is we have to calculate the line equation. It has two properties. One, it is passing through the point 1, 1, 1. In other words, it contains the point 1, 1, 1, and it is intersecting the lines, line 1 and line 2. So if you visualize that, let me say this is my line equation. It is having the point 1, 1, 1. Now it is intersecting the two lines. Say this is line 1 intersecting, this is line 2 intersecting. Now, since the lines are given in unsymmetric form, we are going to represent the required line equation also in unsymmetric form. So, I am representing the answer in unsymmetric form. It means that I feel that the required line is nothing but the intersection of two planes. This is my idea. Okay? Are you clear? So, for the first line, I apply pi 1 plus lambda pi 2 equal to 0. So, it is nothing but 2x minus y minus z minus 2 plus lambda into x plus y plus z minus 1 equal to 0. In order to determine lambda, since it is given that the line passes through the point 1, 1, 1, I substitute 1, 1, 1 here, I will get lambda value. So from this I get lambda is equal to 1. So if I substitute lambda is equal to 1 there, then I will get the plane equation as x minus 1 equal to 0. If you substitute lambda is equal to 1 here, the respective plane equation is nothing but x minus 1 equal to 0. Similarly, for the second line, I will apply, say, pi 3 plus mu pi 4 equal to 0. So it is nothing but x minus y minus z minus 3 plus mu into 2x plus 4y minus z minus 4. Again, I substitute the point 1, 1, 1 here. I will get mu value as 4. Substituting mu value here, you will get the plane equation as (9x minus plus 15y minus 5z minus 19. So I have represented the required line equation in unsymmetric form like this. Please check on the approach. So the question is, please take a note of the problem. Then let us discuss with the approach. Right. So here we need to find the equation of the line whose DCs are proportional to 7, 4, minus 1, and it intersects the lines. Two lines are given that. So the simple visualization is, let us say these are the two lines, L1 and L2, and this is our required line L. And what it is given that if we calculate the DCs of this line, it is proportional to 7, 4, minus 1. So understand that the required line is intersecting the two lines. So do you agree with this figure? Now, if you observe the first line, you can convert this into symmetric form very easily. You just divide with 3. Then what happens? We have x minus 1 by 3 is equal to y minus 3 by 1 is equal to z plus 2 by 1. Accepted? The first line will be written like that, and the second line will be as it is. So what happens if you take the parametric form here, R, so you have x is equal to 3r plus 1, y is equal to r plus 3, z is equal to r minus 2. Similarly, for the second line, let us write the parametric form. So you have x is equal to minus 3s minus 3, y is equal to 2s plus 3, z is equal to 4s plus 5. Why I have considered the parametric form? Because the required line is intersecting the two lines. So for a particular value of r, here you get a point of intersection, and for a particular value of s, you will get the point of intersection here. So what happens, in order to calculate the drs of this line, we should take the difference between the coordinates, difference of x coordinates, difference of y coordinates, and difference of z coordinates. Clear? Are you getting it? So if you take the difference, so you have taking the subtraction this minus this, if you perform 3r plus 1 plus 3s plus 3, r plus 3 minus 2s minus 3, r minus 2 minus 4s minus 5. So nothing but 3r plus 3s plus 4, comma, r minus 2s, comma, r minus 4s minus 7. Accepted? Yes or no? The dr values. Now understand that the line drs are proportional to this one. So these three values are proportional to this as per the given problem. So if you consider the respective fractions, we will write 3r plus 3s plus 4 by 7 is equal to r minus 2s by 4 is equal to r minus 4s minus 7 by minus 1. So apart from taking the proportionality constant, straight away let us cross multiply them. Cross multiply these two fractions, you will get one equation. Cross multiply these two equations, the two fractions, you will get another equation. So if you take the proportionality constant, it is a lengthy procedure. You need to solve more number of equations. Apart from that, you can do cross multiplication. So on solving that, you will get the values as r is equal to 2, s is equal to minus 1. So the respective points are nothing but, here you will get a point 750, here you will get a point 011. Clear? Now, in order to write the required line equation, since you know the 2 points on it, you can write the 2-point formula to calculate line equation. So is it required for you to write the 2-point formula for writing the line equation? The formula is nothing but x minus x1 by x2 minus x1 is equal to y minus y1 by y2 minus y1 is equal to z minus z1 by z2 minus z1. This is the formula. So you know the 2 points on the required line. Using this formula, you will get the required line equation. That was the procedure. So we directly use drs here because you have mentioned it is proportional, right? That's why we have taken directly. Because this and drs proportional, hence we are eliminating the proportionality constant, the proportional fraction value. Straight away we have taken the values like that. So if you have noted this, I will take the other point. Now we are going to take the concept of skew lines. So skew lines are nothing but, if you take two lines L1 and L2, they must be neither parallel nor intersecting. And usually skew lines are non-coplanar. So if you say that L1 and L2 are skew lines, then L1 belongs to one plane and L2 belongs to the other plane. Okay? So for a rough diagram, you can say that this is L1 and this is L2. So don't misunderstand that if you extend these two, are they meeting? No. So you have to visualize that. So this is L1 passing to the upward direction, and this is L2 in the downward direction. One is going like this and one is going like this. So these two are skew lines. Okay? They are not parallel and not intersecting. Fine? Now the thing is, you have to calculate the shortest distance between the skew lines. We call them as SD. The shortest distance between the skew lines. Now what happens, there will be exactly one line which is perpendicular to both the lines. So in the space, it is possible to draw exactly one line which intersects the two given lines at right angles. So obviously you will have the point of intersection. So the distance between these 2 points, we call it as shortest distance between the given lines. Now as usual, if you think about the coplanarity case and what we did with regard to the problems, here also in skew lines concept, you have to evaluate the shortest distance between them in 3 cases. So case 1, the 2 lines are in symmetric form. Case 2, the mixed one. Case 3, 3 lines are in unsymmetric form. So in the possible 3 cases, whenever 2 lines are given to us, we have to evaluate the SD, the shortest distance between them. And one interesting thing is, since this is the distance line, so you have to write or you have to find the equation of the SD line, the line of SD. So generally we represent the line of SD in unsymmetric form. So how do we represent? We have to calculate 2 planes, one plane containing this part, another plane containing this part. So these 2 planes intersect. This intersection is nothing but the line of SD, the distance line. Okay? Is the context clear? And if you want to know the shortest distance between the skew lines, if both are given in the symmetric form, there is a shortcut formula. Let us use that. It is so if both the lines are given in symmetric form, so you have the DCs as well as the points on them. So using this formula, the determinant value divided by square root of that thing, which gives the distance value straight away. So here we are just calculating the SD, we are not calculating the line of SD. Okay? So at this point, I want to conclude about our today's session. So in the next session, we will discuss about skew lines problems. Then I will take some other concepts with regard to right line. Then we conclude our discussion. I think you have given an assignment of our planes. Could you check on that in the group? Thanks, and that's all for today.